Okay, we're going to look at the quotient rule for derivatives. So as the title indicates, your function is going to be in the form of a quotient or a fraction if you'd like. So I've got this one here, 5x cubed plus 7 over 9x squared plus 4x. So what we're going to do, we're going to set up this 1, 2, 3, 4 that I introduced with the product rule, but it's just slightly different. 1 is going to be the numerator. So I'm going to write that next to 1. 2 is going to be a derivative of that. So that would be 15x squared. 3 is going to be the denominator. And 4 is going to be the derivative of that. And again, when we're taking these derivatives within product rule and quotient rule as we're doing here, you could be using power rule, you might even have to use a product rule again, or even a quotient rule again. It all depends on how the function is displayed. Now, when you set up your derivative function, it's going to be like this. A little bit different than the product rule. It's going to be 2 times 3 minus 1 times 4 all over 3 squared. Again, you would learn the proof and why that works and the definition of the quotient rule in your calculus class. All this is the same thing as that definition, except I just think it's a little bit easier to apply 1, 2, 3, 4 instead of all those symbols that you have to encounter when you're learning the proof the first time. So again, I like to do that 1, 2, 3, 4 chart, and then we're going to slide everything in. So 2 times 3, that's going to be 15x squared times 9x squared plus 4x minus 1 times 4. Actually, I'm running out of room here, so I'm just going to give myself a little bit more room here. Okay. So 2 times 3. So 15x squared times 9x squared plus 4x. Subtract 1 times 4. So 5x cubed plus 7 times 18x plus 4. So again, making that 1, 2, 3, 4 chart is really handy. Then you can reference it. And then all over 3 squared. So that 3 was 9x squared plus 4x. Now again, depending on how your teacher or how your classmates or how you are personally going to simplify that, you would take it from there. One thing though that I never have my students do is I never multiply out this denominator, that 3 squared. I do have them simplify the top. Again, anything that's obvious common factoring we do. But again, that all depends on your teacher and your class and your own personal taste on how far you're going to simplify it. But as far as everything goes, as determining the rate of change at a specific point for this function, this right here would be good to go. All right, that's a quotient rule, and we'll see you in the next video.